My name is James Garfield. I work for AdBlock Software. I'm going to talk today about functional programming. And that's not just code that works. That's not what that means. Functional programming is a style of programming, much like procedural programming and object-oriented programming that I'm sure you all know, but I find that fewer people really know about what's going on with functional programming. So I just wanted to share some of that with you today, because I find that knowing many different ways to think about programming leads you to more solutions in your own head. So let's talk about JavaScript for a moment. JavaScript is a multi-paradigm language. And what that means is some languages, like Java, are very strict about how you do everything. Java is strictly object-oriented. Everything must be a class or an object of some sort, and that's how everything is done. JavaScript is not like this at all. It's you can do anything any way you want in JavaScript, and it's a lot of fun. The first way you can do is procedural. It's what a lot of us do. We write our functions, our methods on forms. We start at the top, work our way down, and it's a very classic way of programming. That's procedural. It's all about thinking linearly. Then there's object-oriented programming, like Java, or if you're creating new objects in JavaScript as well. It's about classes and structure and hierarchy and making things generic. And it's also kind of a very familiar paradigm for people. But JavaScript also does functional. And I like to think of functional programming as being about being expressive and being flexible about how things work and how you want things to go in your code. And what functional means? One of the main things in functional programming is that functions are first-class objects. And what that means is you can do the same things with functions that you can with any other data type, like a string or a number or any other kind of object. They are objects just like anything else, and you can treat them as such. So you can assign a function to a variable. Here I define a function called square that takes in an x and returns the square of x, and I assign that to x. And then you can see below I can do x, I can call that function as x with 2, and I would get 4 back. I could also do square, and you can do it either way. So right now, x and the function square, they point to the same thing. Yes? Okay. Yes, because that is how you call a function, is you put the parentheses on the end. You can pass them as arguments. So we have the same square function that I put into x, but now there's another function, do math, that the first parameter is a function. It's expecting a function as its first parameter. So I take x and I pass it to do math, and do math will go do something with that function and the other parameter that I pass in. You can return them as values, so much like you can pass them into something else, you can return them away from a function. So if I'm defining square inside of another function, I can, in that function, return it. And now whatever function called that has that function as its return parameter. Clear? Yes? And they can also be anonymous. They don't have to be named. If you've ever used arrays, sometimes you need to sort them in a certain fashion, and by default they will sort in numerical order if it's numbers. Maybe you need it to sort backwards, so you can pass the sort function of arrays another function and tell it how to sort that. So if you sorted the array A, 1, 2, 3, 4, 5, with this function, it would reverse it. It would now give you 5, 4, 3, 2, 1. And so the sort function took a function as a parameter, but it didn't need a name. So you can see here Normally, I'm giving a function a name, square, but I don't need it. It doesn't need to know what the function is called, it just needs to be able to call it. And so we don't give it a name because it doesn't really matter. The one thing you can't do if you don't name a function is use that function recursively. Because if you're going to do recursion, you need a name, and therefore you're going to have to call it something so that it can call itself again. So now we know all this. What can we do with that? How is that useful? It's useful a lot with arrays. I always seem to come back to arrays because they're my favorite collection, I think. And if any of you have been around Servoy for a while, arrays in 4 and 5 got some new functions attached to them. One of them is called for each. So you do array.forEach. And what that means is you're saying, I want you to do this for every object in this array. So I'm going to give you a function, and you're going to pass every object in that array into this function. So this quick example, we start and we have the variable sum as 0, and the array 1, 2, 3, 4, 5. And so I say, okay, for each value in this array, I want you to add it to sum. And I see I have a typo in there. I didn't pass a parameter in my function. Sorry about that. But what this would do is, after this runs, if we output the information, it would be 15, because it would start at 1, and it would do 0 plus 1, plus 2, plus 3, plus 4, plus 5, and you would get 15. And normally, you would have to write a loop for that. But this kind of takes that entire idea of looping over an entire array and encapsulates it into one line of code. If there are questions at any point, just let me know immediately, because if we go by, it would be better to answer the questions immediately. Another one that's similar, but it's slightly different, is called map. And this will also do it for every element in the array, but it also will store the return of each call to that function in another array. So you start with one array, and you get another one out. And it applies an operation to each value in it. So we have the same array of 1, 2, 3, 4, 5, and we have our square function. And on the next line, we say, okay, let's make another array, square A, and we will map the square function onto our original array. So the first thing it does is it calls the square function with every item, 1, 2, 3, 4, 5, and every time it does that, the square function returns the square. And so now at the end of it, square A has the squares of all our numbers. So we didn't just call the function this time, we also captured the results. So now you can do an entire series of operations all at once and see how they turned out, which is pretty cool. And then there's also filter. Filter is, I have a collection of things, but I only want some of them. In this case, I have an array of 1 through 5, but I only want the odd ones. Another typo. People should really proofread these before they go on. And so what happens is we have the function isOdd, and it just checks the modulus of x, and if it equals 1, it returns true. If it does not equal 1, it returns false. And so we apply that. This is supposed to be A, not square of A. So we filter that array, and we get 1, 3, and 5, because they are the only odd ones in that array. So now we've started with one array, got a different array that's smaller. It has only the elements we want in it. Okay? Why are we doing this? What's wrong with loops? I'm sure many of you are asking, yes, but I know how loops work, and I know how they're very clear, and why would I want to do it differently? it's about the signal-to-noise ratio. Signal-to-noise ratio is a concept of when you get a lot of information, some of it is very important, and that's the signal, and some of it is noise. It's not important, it's just extra information coming at you. So for the sum example, we can do it with a loop. And let's talk about what exactly is going on in this small scrap right here. We say, okay, we're going to define a variable sum and set it to 0. We're going to define an array and fill it with the numbers 1, 2, 3, 4, 5. And now we're going to start a loop and declare a variable I and start it at 0. And then I is going to go until it is less than the length of the array A. And every time we go through, we're going to add 1 to I. And then in the loop, we say, okay, to sum, I want you to get the element at the index of the array of I and add it to the sum. That's a lot of information when all we're trying to say is add it all up. It's a lot of words I just said. So with the for each example, we could put this on one line and it would be less code, but sometimes this is more clear. We start the same way. We say, okay, sum starts at 0, fill the array with 1, 2, 3, 4, 5, and now for every element of the array, add it up. It takes the algorithm of a loop and it encapsulates it into something very small. So now you know immediately what that's doing. And sometimes it can save on bugs, and we all don't like bugs. With a loop, it's simple, but a lot can go wrong. Sometimes you might start at the wrong index. You might forget and you might do 1. Because sometimes when you're looping over a found set, that starts at 1. If you're looping over an array, it starts at 0. And sometimes it's hard to, you make a typo and you mess it up. Sometimes you will choose the wrong operator for your compare. You might do less than instead of less than or equal to, if you're supposed to switch those around. If you have nested loops, now you've got to keep track of 2 sets of variables. You know, this loop, and don't increment the wrong one, and don't name 2 loop variables the same thing, or everything is going to mess up. And so when you kind of encapsulate the idea of looping and doing the same thing for everything, you've kind of taken that possibility of bugs out of the picture. It's just not going to happen this time. And all you have to do is make sure your tiny little function, if it works, then it will work for all of them. That's how I think about it anyhow. What's faster? That depends. When the for each and the map, it has, I believe, technically, and someone who's maybe a back-end programmer should correct me on this if I'm wrong, but for each can be implemented in the host language as opposed to the scripting language. So in our loop, this is all JavaScript. In the for each, I believe the way it's defined is actually Java. So it can be optimized for that. It can have back-end optimizations that now whether or not that's how that actually works, I'm pretty sure that's how that works. I haven't actually looked at how they do it, so I'm not really sure. But I believe for each is faster. That is true. You're not checking it every time. That's another good point. And it's not, you're also not incrementing another variable. You're not having to do math on I. It's not a lot of operations, but it can add up, I suppose. Okay. Scope. What is scope? When you start programming functionally in JavaScript, scope is very important. Scope is the context in which a function executes. So a form method the scope it executes in is the form. It can access form variables because they're on the form and therefore they're in the scope. It can access other form methods and that method's local variables. So if you define variables in that function, it can access those. They're in the scope. Other form methods are in the scope, and the form variables are in the scope. If you have a function on the form, and then you define another function inside of it, that inner function can access everything the outer function can, the form variables, other form methods, local variables, and it has access to the parent's local variables. So if the outside function defines a variable A, the inside function can also access and modify those variables as well, which seems to make sense. You know, it follows. What's interesting is, much like if you call a form method from outside that form, from another form or from the global scope, it makes sense that that can now access all the form stuff. But we've talked about how you can pass functions around. And if you have a function inside another function and you return it, it carries its scope with it. This gets a little complicated and we'll have examples of it soon. But what that's called is a closure. It closes in its scope and it carries it around with it like a bag. And what that allows you to do is it gives, kind of simply, this is oversimplifying, it gives that function the ability to remember things, kind of. A quick example that doesn't have a lot of use inside JavaScript, but it's a good example, is a generator. So we have something a little complicated here. We define a function, this, and what this function does is it has a variable x, 0, sets it to 0, and then it returns another function that when you call it, returns x and then increments it. So if you, and this outer function here, the one that returns the function, the way I've defined it, I define it, and then with the parentheses, I immediately call it. So it's kind of a throwaway function that's only purpose was to create this and return this with its kind of encapsulated scope. And we've returned it into the variable gen. And so if we successively call gen and output the information, we get 0, 1, and 2, because every time we call it, it goes and it looks at x and it increments it. It's because, and you might think that's a little crazy, because usually when you have local variables in a method, the next time you call it, they've all been reset because they went away. But because it's keeping its scope, it's keeping that external package with it, that outer x, it doesn't go away. It sticks around. Every time you call it, it will always be there. So you can pass it to one function and use it, and it will increment, and you pass it to another function and increment it. It will just keep going until you get rid of it. And every time, if instead of a throwaway function once, if this was a global function, I could call it and get multiple generators, and each one would have its own copy of x that would increment separately from all the other ones, but they would keep it in between calls. Is that clear? Yeah? Okay. Something we can do with closures are partially applied functions. What is that? Partially applied functions are a use of closures that supplies some or all of a function's arguments now, but allows invocation of the function later with the rest, if any, of the remaining arguments. what? Let's look at some real code for a minute. So, I have a very beautiful UI. I worked on it for a long time. Can we see it? What we have here is, this is just on the example database. We have a customer detail form, and which is what you see here. And we have a customer chooser form, which is just a list of customers, and it's something to use in an application show window. And all it does is, when you show it, when you call it, you pass in a callback function. I think at least a lot of us have used callback functions, right? Maybe if you use the headless client plugin, or if you do a lot of web programming, callback. It's an idea of, when you're done doing what you're doing, call this function. So you pass in, to make this a generic kind of, this chooser can be used for anything form, you pass in a function. And we store it in this form variable callback. And then we show this form in a dialog. And when you press the choose button to choose it, the action that's performed is the button choose. And it closes the dialog, and it calls the callback and passes the customer ID as the only argument, because you're choosing a customer, it returns a customer to the function of your choosing. So that's good. And so if we want to use it in a situation where I'm looking at one customer, but I want to look at a different customer, I can show the customer. I can choose show. I can get my list. I can go pick a new customer. I can choose it. We're looking at Morgenstern, and now it loads it. And so the code for that, let's take a look in button choose. Nope, that's not what I want at all. Button show. So I call the customer chooser, and I say show the chooser, and I will pass it the callback function load customer, which load customer we can see right here takes a customer ID, makes sure it's defined, and then shows that customer. Pretty straightforward. So, yes? This right here? I will show you how that works. We can step through this so it's more clear. If I can set a breakpoint, maybe. So when we click show customer, no. Sorry. Relaunch the debugger. Relaunch the project. When we click show customer, I call the show chooser, and this load customer right here is this function. So I'm passing it this function as the argument. And I step into it, and the customer chooser, boom. Customer chooser has a form variable called callback. And so I'm setting the incoming, I take the incoming function, the callback, and set it to that. So that's what callback is. It's just a reference to whatever function I pass in, which in this case is my load customers function. Can we see it? Yes, we can. If I look at the we can see that it's a function, and it's called load customer, but it's just in that variable now. And so we step through, and it sets it to that, and then calls the dialog. And we get it, and we can choose. And we call the callback. Okay. So that's a very simple, that's how the customer chooser works, and that's how we originally designed it so that it passes one customer ID back. What does this have to do with functions or closures or partially applied anything? What if, because sometimes in the industry, customers, they have mergers, they consolidate. What if two customers that we have are joining together? They're becoming one company. And so you need to merge one customer into another one. And so you have a no. A merge customers function that takes two customer IDs. It takes the one we're going to keep, and it takes the one we're going to merge into it. And so we're looking at the customer we want to keep, and we say, well, I know who I want to merge into it, and I'm thinking, well, I have this customer chooser, and I really want to use that because it's my standard interface, but the merge customer function takes two customer IDs, and my customer chooser only returns one. And even worse, it returns it in the wrong place. The one I want to merge in is the second argument to merge customers. So how can we go about dealing with that problem in a functional manner? There's always another way to do it procedurally, but there is a way to do it functionally. And how we do that is we create a closure. We keep and we partially apply the merge customers function. So what happens here is the code, this function, the external one, creates this inner function that takes one variable, merge customer ID. And it returns, when called, the result of calling merge customers with current customer ID and merge customer ID. Now, where did current customer ID come from? Up here in the button code, I define current customer ID as whatever the found set is currently showing, that customer ID. And so this function gets called immediately, because we have these parentheses at the end, and it creates a function that we pass into the show chooser. So this we're going to step through because it will make a little more sense if we can see this work as it happens. And we'll even do it here just in case. Okay. Yes. So we call merge customer, and we see this is defining this function, and I go to the proper, and if we look at what my callback is, I don't see it. I don't know why that is. It's a function. And we pass it to the customer chooser, as we saw earlier, as a callback function. We get our window. We choose blonde P. So we're on bon app, this customer ID, and we're choosing blonde P as the one we're going to merge. And so we call this, and it goes into the callback. And you can even step into it. And what happens is now we're back here, where we originally defined this function. And this is going to return the result of merge customers with these two variables. But you're thinking, well, we defined current customer ID earlier, and we've left that function. It's not still around. But because it's a closure, it is still around. And we can look at current customer ID, and we see it's bon app, which is what we were on. And we can look at merge customer ID, and it's blonde P. So you can see we have both the variables we're looking for that will get passed into merge customers, and we get the result, and now they're merged. And so we just transformed our 2-argument function, merge customers, into a 1-argument function that just took the customer we wanted to merge so that we could use it with our handy-dandy little customer chooser. Yes, there are other ways to do that, but that's the functional way to do it. Are there any questions about how that worked? Okay. Now, what we did, it's called partially applying. But doing this all the time, you might be thinking, well, that's crazy. Why would I want to type that all the time? That's a lot of code. This idea of partially applying a function has been formalized into a method called partial. It partially applies. And partial takes a function and as many other arguments as you want, and for every argument that you define, it will apply it to the proper place in the call structure for the function you call. So let's take a look at partial. It's a little complicated, but you don't really have to know, you don't have to look at this all the time. It works for everything. So if you've played around with arguments at all, you know it acts like an array, but it's not really an array. So what we're doing here is we're getting the slice function away from the array object, and we're telling it to use this function, but use it with the arguments object. And that's kind of a way of getting around the fact that arguments doesn't have slice. So what we do here is we get all the arguments except the function, so anything else you passed, and we kind of return another function that when that function gets called, it takes the arguments you had before, the pre-args that you passed in when you partially applied, and it loops through them. And it says, if I didn't pass something in this position, use what I passed this time. If I didn't, use what I passed the first time. So that lets you apply functions in any position that you need when you call it. Very clever. I knew I would get that. It was a test for you. You win the prize. No, it's a good question. Why didn't I use it there? I'm a big proponent of using the style of programming that makes sense to you at that moment, or that you think will fit or express what you're trying to do the most clearly. I'm not here today to tell you you should always be functionally programming. You know, I don't believe in that, and I'm not going to say you should always object orient. You should always procedural. Use what's comfortable. Use what you feel fits the situation. For this function, I felt a for loop. It would just be a little easier to express what I was doing for this. I'm not sure how I would do it the other way. I could probably think about it for a while and figure it out, but this was easy at the moment, so that's why. Because at the moment, that's how I felt like doing it. So this is a little complicated, but what that means is instead of doing this every time, we could just replace it with this, which is much shorter, much easier, and pretty clear. And again, it gets back to this idea of being expressive and encapsulating a larger idea into a much smaller one that's easily defined. So, because if you know what partial does, now you have a very quick way to say, just put these in here beforehand. I'll worry about it later. And it's much easier. So right now we're using current customer ID and we're saying apply that to the first position of the function. If the merge customers worked the other way and we needed current customer ID in the second position, what you do is you'd pass it like this. You would not define the first argument, and so it says, oh, I should skip that one for now, and it applies current customer ID to the second part. And so when you call the function that partial returns later, it will fill in the first one instead of the second one for you. But this one takes it as the first one. And so that's partial. And partial is pretty powerful. It encapsulates a lot of functionality in something very small. Another thing you might want to do, sometimes we have a found set, and we want to do something for everything in that found set, right? We want to say send a fax to all of our customers. We have a fax plugin. We're going to send a fax to all of them announcing some sort of event, some sale we're having. Here, come buy our stuff. Give us money. There are two ways to do that. You can do it the loop way, procedural way, or you can do it functionally. Yes? Correct. So the question was, because partial doesn't give a name to the function it returns, you can see where I define the function, it has no name, it means you can't use it for recursion. However, if this was yours, there's no reason you couldn't give the function that partial returns some sort of name, maybe underscore or anything, and that would be kind of your notation for it, and then you would be able to use it in recursion. I hadn't thought of that. I should try that. That sounds like fun. It's a very good question. Thank you. So, we want to... Yes? No, it would still work because in the web client you do have the button, right? With that, I don't have any code after I show the dialog. I don't need it to wait because I have the callback. It should actually work better for a web situation because a callback function is actually a very kind of web-oriented design thing. It's used all the time. It's a bit better actually because you're not relying on the modal dialog to pause your code. And so if you maybe suddenly have an unmodal dialog, you want to just have multiple windows, you're still not relying on it, you're using the callback function to do something at the proper moment, as opposed to, the way you could do that procedurally is you'd wait for it, and in the dialog, instead of calling a function that passed a customer ID, maybe you'd end up having a global customer ID that got set, or a form customer ID that got set, and then you'd have to go reference that outside of that, and it's a bit messier actually. What are we doing? Faxing, thank you. Okay, so mass fax procedural. It's pretty straightforward. We have the loop, we define the variable, and you can see here, unlike my array, you have to remember, you got to start at 1 for found sets, you have to go less than or equal to get size, and this is bad coding, you should get the size outside the loop so you don't call it every time. You add it up, you get each record, you check to make sure the fax number isn't null because you don't want to send it to no fax number, it would probably cause an error, and then you call the send fax with a message. That's how it works, pretty simple and straightforward. But if you want to do it functionally, it looks a bit different. And I'll have to explain some of these helper functions. If you want to do like this, you're probably going to end up defining a couple of your own helper functions. So let's take a look here and see what this does. First, we start with all records. And what all records does is it just returns every record in a found set as an array. Pretty simple. And the reason I didn't do for each here is because you can't do it on the found set. So you have to use what's appropriate at the time. And so it's very simple. It goes through and gets every record out of the found set. It's a very simple operation, and it's not hard to always know what globals all records does. You pass it a found set, you get an array back. It's very simple. Then we have the column getter function. And this is definitely a helper function for functional programming, very specifically. What it does is you pass in a column name, and it returns a function to you. And what that function does is whenever you pass in a record to it, I guess this would work for an object too, or anything that has properties, it would return that property to you. So column getter returns a function. An isDefined is another function that's very simple. It just tells you if something is defined. Checks to see if it's not equal to undefined. If it is defined, it returns true. If it's not defined, it returns false. These are all three of these tiny little functions are very simple. It's hard to introduce bugs into them. And they're concepts when you're writing code, you can easily remember, oh, this does this. And once you test them once, they should always work. So functionally what we're doing is we pass in the message we want to send, and we say, okay, send fax takes two arguments, the fax number and the message we want to send. So we have the message we want to send, so let's just apply that argument right now, get it out of the way. And it's the second parameter. So we pass the first parameter as undefined, and the second parameter is message. And now we have a new function, we'll call it, it's a local version of sendFax, that we can now call locally that already has the message applied. And then we have this. This is actually, this block is one line of code. I split out into several lines just for ease of reading. You could have it long. I like to break it up so you can see each step individually and understand it as it or see what each step is. But what's nice is, unlike your loop, if you know your loop works, you just want to get your debugging, you want to get by your loop in code, you either have to set another breakpoint after it, or step all the way through it, which can get repetitive after a while, hitting F6, 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 F6. With this, you can just F6 over the entire thing, because it's one step. So each step, what happens? Globals all records pass in the found set. That gives us an array of all the records in the found set. And then we will map, and remember, map applies a function to every element in the array, and it returns the result into a new array. We'll take that the array of records, and we'll map the column getter with the fax. And what that will do is it'll turn our array of records into an array of fax numbers, because that's all we need right now, is just the fax numbers out of those records. And the filter says, well, I only want the ones that actually have a fax number. So any of them that are null, get rid of those. And then for each of those that are left, after I've filtered them, send the fax. No, there's more. And each of these steps maps to something in the procedure, in the procedural way. So the all records, that maps to this outer loop. This outer loop is all records. They perform the same thing. It actually even does this part of it as well. The filter is this part. This is our filter. But we've encapsulated the idea of only doing something for some things into this idea of filter. So instead of having to say coming up with logic and writing an if statement every time, we can say, well, I know the idea of what I want to do is to just get rid of some of these things, and there's a very simple rule to get rid of them, and so we can filter instead. And then for each, that is kind of the internal this bit. So everything kind of has a parallel in the opposing thing. And you don't have to do this all in one line like I did. You can, after all records, store that in a variable. Yes?
Just wondering, in the procedural way, you're going to do your loop once, but in the functional way, you're going to do your loop 3 times. You first loop through all records, so it's the time set.
Yes?
Push in an array.
Mm-hmm.
Then you map through all records,
Mm-hmm.
you loop again.
Yep.
And then you fill it, and you loop again.
Yep.
And you loop for each, and you loop again. It's 4 times.
Yes.
From a performance reason, I would prefer to take the first one.
It is different. Yeah, it is true. No, it's true. It's true. It's a very good point. But the looping is an inexpensive operation.
Yeah. If you're doing that about 1 million records, have fun.
Absolutely. If you're going through 1 million records.
So it's not very scalable, I think, at that point. You can do it with about 1,000, 5,000, 10,000, no problem. But if you're getting a real big database and real big tables, and you do the whole file set, this can be really cost expensive.
I would, perhaps. I would actually like to run a comparison to see how much different it actually is, because like I there's sometimes you have to optimize, and you got to change your code to optimize. I would like to know how much of a performance hit you would take from just the extra looping. Yes.
But you're not doing 1 extra loop, you're doing 4. You're doing 4 times the same thing by that time.
It is true.
Conceptually, this is much more elegant. Performance-wise,
The other thing is, besides the multiple looping, aren't you also grabbing lots of memory to open up all these arrays and do all these operations? Whereas in the first one, you're only having to do it once.
Actually, because I'm never assigning it into anything, it only kind of works on itself. That memory is never kept. It goes away very quickly.
Doesn't matter. It's still in the session. You have to grab lots of memory to open up and copy arrays, and that's another performance issue. You got memory caching, and then you have speed. If you're on a multi-user.
I guess I should have done more investigation on the performance of these things and larger things before I did this. There are outer bounds to everything. If you're looping over 1 million records, you're probably not doing it on the found set anyways, because that's not how I would do it. If I'm looping over a million things, I would probably query the database and get them back. I'd probably even get them back in chunks, so I wouldn't have 1 million all of them at once. There's many different ways to deal with performance. I can't tell you exactly how much of a difference this makes in very large situations. For normal operations, they're very comparable. Anyone else?
Well, I think the performance stuff aside, you're demonstrating the fact that functional programming, you're composing something of functions.
Yes.
And each function is small and
Yes.
And it's a different paradigm.
It's a very different paradigm. I don't know the numbers for JavaScript itself. There are languages that are strictly functional that perform very well over large loads using exactly these methods, very, very fast. And they may consume a little more memory, but maybe if you're worried about memory, we're not working in Java to begin with. But we can see, we can test this, and we can see if they work the same. We have 11 records here, and we see that some of them don't have fax numbers, some of them have fax numbers. We can do it procedurally, and we can send the fax to all the different fax numbers in our list. You'll notice that none of them are null, and we only sent it to about, I think it was eight or 9 records out of the 11. And that was the procedural way. The functional way, nope. Nope. We see it does the same thing. We could. It's so much slower. And I've probably lost all of my memory on my machine at this point in time. No, it's true. For performance-specific things, you may have to tune it. Not all of your operations need to be performance-tuned, though. You don't want to pre-optimize all the time. And like I said, there are certain situations. Use the method. All I'm saying is use the method that is appropriate for what you're doing. Yes. So maybe if it's performance, you don't use functional. Maybe if you have a simple function that you say, oh, I could totally express this functionally. And maybe when I do that, I will skip having to write loops and having to do tests a certain way, and it will give me a lower chance of introducing bugs into my code. It'll be easier to find them because there are only so many places they can happen now. It's a toss-up. At the mathematical root of functional programming and procedural programming, they're equivalent. The math behind it is all the same. If I was a mathematician, I could show you, but I'm not. Any questions as we go on? This solution will be part of the stuff you get afterwards, and so you can look at it and test stuff and see how it works, in your code space if you'd like.
Just have a question about the fact that it goes through the loop.
Mm-hmm.
I thought that, the fact that it's separated by dots,
Mm-hmm.
I thought that it would just start at the first one,
Mm-hmm.
verify the condition, and if it was okay, it would go to the second one.
No.
Through every single one, 4 times.
It goes. It resolves each function call first in order. So it resolves all records first, and then it resolves all of the map operation, and then all of the filter operation. So because each one of those returns an array, you can keep calling array functions on the return, which is why you can chain it like that, because each time you've got an array back and you can do something with that. Anybody else?
Wouldn't it be better, just wondering, if you filter before you map?
If I filter before I map,
Filter everything and then you filter. Why don't you filter and then you map? So you will have to map less.
I can show you. Because before I map, I have an array of records. And isDefined takes in a value and sees if it's defined. So if I filter before I map, what is defined will get is a record. And is that record defined? Yes, it is. It's a record.
And hence the method is defined.
You could do that as well. Yes, you could totally, here, watch, we can do it right now. You could do dot, and you could say filter partial no, I think it would be more difficult than that. Function, we get a record. Function, record, return. Is defined r dot facts. Dot map. Dot for each send facts. And that would do what you were looking for. Look at that. You're thinking functionally already. I have already won. Time is up. Thank you all very much.